July 4th, 2012, and scientists from Cern, the European Agency for Nuclear Research, step in front of hordes of journalists to unveil a scientific discovery that signals a new dawn in understanding our universe.
It is a milestone. I think we can all be proud.
Researchers created what's been called humanity's largest and most complex scientific experiment. A 27-kilometer, one-of-a-kind machine buried some 175 meters below ground to discover the Higgs boson, a pivotal building block of our universe.
So the Higgs boson is a fascinating particle because it's the simplest one. This has completely changed our vision of also the universe, because corroborating the fact that there's a Higgs boson means that we live in a vacuum that is very special. So it has changed a lot on the way we think about our universe in general.
The boson is part of what physicists call the Standard Model, a way of explaining what for 13.8 billion years has held particles together, maintaining our universe. There's just one problem. No scientists had ever detected it. That's where the Large Hadron Collider comes in.
So we're accelerating protons in opposite directions to very high energies in a 27-kilometer long tunnel, and then we bring them to collisions in different interaction points where we have then experiments essentially recording the data.
Okay, Olivier, why don't you tell me what's happening here?
What we see here is an event display, which essentially is a recording of one of our proton-proton collisions. If you like, it's a three-dimensional imaging of the data we are taking in our experiment and then being displayed in this way. So it's one out of billions of collisions we are taking.
So this is like real-time imagery of what you're trying to do here.
Teams like Oliver's from Geneva to Chicago analyze the debris of millions of collisions. Collisions, they say, recreate the beginnings of the universe.
What are you hoping to achieve here?
Well, these collisions essentially are at very high energy, at the highest possible energy mankind has generated in particle physics collisions so far, and we hope to achieve conditions which must have existed very close to the beginning of our universe, namely after the Big Bang.
Of course, recreating the Big Bang is not a matter of just flipping on a switch. The LHC is managed by a control center on the French side of the border, where engineers like Mirko are responsible for injecting some 7 tera-electron volts into magnets, accelerating protons close to the speed of light.
On this screen, on this chart, you see the past 24 hours at the LHC. You see the black line indicates the energy of the machine, and the blue and red lines indicate the intensity of beams that are injected in the two directions into the LHC. We actually put them into collisions where the experiments can turn on their detectors and start collecting data.
If something was wrong with the machine, what would this chart look like?
Something like that, for example.
Is that telling me something's wrong?
Yes,
okay.
Indeed. We decided to extract the beam, restarting from zero, and it went smoothly up and this time, and it was pretty fine.
And while the machine runs smoothly now, that wasn't always the case. In 2008, after a decade-long construction, disaster struck when a short circuit caused an explosion that rendered the machine inoperable.
Tell me about the worst day ever in this command center. What happened that day?
2008, when we broke the machine just 9 days after switching it for the first
You
time.
broke the machine?
Yes, we got a technical problem into the ring, and there was one of the sectors that experienced an electric short, and actually there was somehow a small explosion inside the magnets. That was the worst day of my life. Everything got red on the screens.
The team almost halved the energy used by the system for the following years, so when they discovered the Higgs, everyone was a little shocked.
So there's a period of disbelief. Of course, as an experimental physicist, and when you're through observing something new, you just try to make sure that you're not observing something fake. When we finally accepted that it was there and started to study it, so it was an incredibly exciting period.
But the Higgs discovery also reveals how much we still don't understand.
Now we really want to go beyond that model, because we know that it does not explain everything we see in our universe. As a matter of fact, it only explains 4% of the matter which we have in our universe. So there's much missing. And with the next phase of the LHC, we are now hoping to make new discoveries which go beyond our present understanding.
In June 2015, the system was turned back on after a significant upgrade, and this time delivering twice the energy used during the Higgs discovery. The scientists say they could be on the path to discover the gravitational forces that hold our galaxy in place, and even, potentially, miniature black holes.
There is theories out there which suggest that these microscopic black holes could be produced in high energetic proton-proton collisions. And if we indeed find first signs of these microscopic black holes, then this could open the path to new extra dimensions in our universe.
But for the team that first discovered the Higgs, now it's not just what they think they might find, but what they've never seen coming.
I would say I have two dreams. One of course, is to see something completely unexpected. And of course, there's also maybe another aspect. There are fundamental theories that are incredibly elegant, incredibly beautiful, on how they explain a lot of the mysteries that we have in our fundamental laws of physics.